So there are two types of convergence. The first one is absolute convergence. So if the absolute value of the series converges, then the series itself converges absolutely. So for the first example, taking that a sub n, which is negative 1 to the n over n squared, and putting that in an absolute value, and looking at that series from n is equal to 1 to infinity. So to simplify that, we have the series as n is equal to 1 to infinity of 1 over n squared. And since we know that the series 1 over n squared converges by the p-test, since the value of p is greater than 1, then the series n equals 1 to infinity of negative 1 to the n over n squared is said to converge absolutely. The second type of convergence is conditional convergence. So if the series of the absolute value of a sub n diverges, but the series itself converges, then the series is said to converge conditionally. So for example, looking at that series n equals 1 to infinity, taking the absolute value of negative 1 to the n plus 1 over n. Simplifying that, this is the series n equals 1 to infinity of 1 over n. And since we know that series diverges by the p-test, since the p is equal to 1, then we need to check to see if the series of a sub n will converge. By doing the alternating series test, checking if 1 over n is greater than 0, which it is for n is between 1 and infinity, and then checking to see if the u sub n is greater than the u sub n plus 1, so taking n plus 1 greater than n, and 1 over n is greater than 1 over n plus 1. And the third condition, limit as n approaches infinity of 1 over n is equal to 0. So therefore the series negative 1 n to the n plus 1 over n converges conditionally. Look at the problem, we're going to see the series as n equals 1 to infinity, take the absolute value of negative 1 to the n squared 2/3 to the n. Simplifying that will make the series from n equals 1 to infinity of n squared times 2/3 to the n. To see about convergence, we're going to do the ratio test. So by the ratio test, looking at the limit as n approaches infinity of n plus 1 squared times 2/3 to the n plus 1 over n squared times 2/3 to the n, which is the limit as n approaches infinity of 2/3 times n plus 1 squared over n squared, which is equal to 2/3, which happens to be less than 1, so then the series will converge by the ratio test. So therefore, since the series of the absolute value of a sub n converged, then the series itself converges absolutely. The next example, looking at the series, taking the absolute value of the a sub nth term. Simplifying that will make the series from n equals 1 to infinity of 1 over the square root of n. And since we know that series diverges by the p-test, since the value of p is between 0 and 1, we now need to check to see if the series of just a sub n itself will converge. By using the alternating series test, the u sub n term is positive for any value of n between 1 and infinity. Checking the second condition, let f of x equal to the u sub n term, so x to the negative 1/2. Taking the derivative, get negative 1/2 x to the negative 3/2. And we know that's going to be less than 0 or negative for any value of x between 1 and infinity. And so what that means is that the function is going to be decreasing, and so the u sub n term will be bigger than the u sub n plus 1 term. So the second condition checks. Now checking the third condition, the limit as n approaches infinity of the u sub n term is equal to 1 over infinity, which is equal to 0, so the third term checks. And so the series converges, and since the series absolute value of the series diverged and the series itself converges, we say the series then converges conditionally.